If we go in this frequency domain, there's two other numbers, low frequency and high frequency. Sometimes they give you one number and like a ratio. Either way, you get two numbers. The low frequency band is between 0.04 hertz and 0.15. The high frequency band is 0.15 to 0.4 hertz. Now let's just cover real fast hertz and the frequency domain so that you can keep that in the back of your mind, or come back to one of these shorts if I can pull it off, that talks about frequency domain. So when you have something, let's call it like 1 hertz, that means that event happens once every second. So hertz is in seconds. That's an easy number. What if it's 0.5 hertz? 0.5 hertz means that half of that event happened in 1 second. Another way to look at it is, you can take the inverse of 0.5. So 1 divided by 0.5 is 2. That's how long it takes to have the full event. If you have a higher number than 1 hertz, let's say it's 2 hertz, that means that that event has happened twice in a second. Okay? So this is where this, again, frequency domain and time domain, like how many miles do I go in time, or how much time to cover a mile, they're really just kind of two sides of the same coin. With the frequency domain, these two bands were found by that biochemical work back in the 80s, again on dogs, not on humans. I believe all the dogs lived, by the way. Woohoo! The goal wasn't to kill them. And actually, again, the variation here isn't what truly creates your sort of static heart rate. It's probably another part of your brain that is represented by this really close to zero curve in this power spectrum. And that's controlled by something called very, very low frequency, which is sort of like, imagine like a set point, a homeostatic set point. Kind of like how your body's weight stays about the same every day, right? There's no day where you wake up and you're 50 pounds less than you were the day before, and then you're 30 pounds heavier. You stay in a pretty narrow range because a part of your brain has said, that's what we're gonna do. That's how much, energy we're gonna allow to flow out of you in terms of fat burning and everything else, and how much we're not gonna allow to happen. Okay, so with the low frequency band, 0.04 to 0.15, and the last thing I want to cover about this before we move on is what's called a time constant. So a time constant tells you, it's that number of like how many seconds does it take for something to happen. So a time constant is very similar again to that idea of, well, if I go 61 miles in an hour, how long did it take me to go a mile? So this is how long does it take for the event to happen. So let's go with the easy one first. A 0.40 hertz, that means that it takes 2.5. So again, you just invert it. So 1 divided by 0.4 is 2.5 seconds. Let's try the different color. So a 0.4 hertz takes 2.5 seconds to go through and have the event take place. So that is 2.5. A 0.15 is about 7. It takes about 7 seconds for that event to fully take place. So again, you can imagine things that take a while to happen having less than 1 hertz, right? If you say something really fast, like, I might have had a really high hertz right there for a D sound. I might have said it, 10 times in a second. But if I say something really slow, Adrian, maybe that took 3 seconds. And if I kept doing it, it would be a 0.33, a 1/3 hertz. Okay, I just dated myself. If you don't know Rocky, I come off like a weirdo. It's okay. So 0.15 is 7, 0.04 is 25 seconds. So last thing I want to get across right here before we move on into like the actual other aspects of this that are more real world is that if you'll notice, there's 2.5 to 7 seconds for one of these bands. More than a second, but not super long, right? Like we're talking less than 10 seconds for something to take place. That's pretty fast in terms of biology. It's, it takes you a while to process your food. It takes you an hour. That's only 10 seconds for something to happen, for a change to happen. The other one, it's a little bit longer, 7 to 25 seconds, but again, not super long. So those time constants become useful later on when we're going to ask some other yellow flag questions about, well, hold on, how do we change ourselves when the numbers we're measuring change really fast? right? That's clearly 7 seconds the longest to an FS7, or 7 to 25 seconds. That's clearly a short process. So if something changes in a short process, how does that short process become a long process, right? How do I have better heart capability 3 weeks from now? That's a lot longer than 25 seconds. So I'll leave that as a yellow flag. I'll leave a couple words here in case you're thinking ahead already about accretion versus depletion models. And if you've been out in this world training or been with trainer, worked with athletic staff, you have definitely been exposed to one of those models. And if you're someone who likes to do kind of treat yourself, self-care, you have definitely experienced one of the other of those models. We'll come back to them at a later pod. Okay,